Hello, everybody. Good morning, good afternoon, good evening, wherever you're tuning in from around the world. Thank you so much for joining us and welcome to the Polyhedra Show. So today is a follow-on from our episode last week, which was the zkML demo, and something really exciting, but obviously expected happened. We were inundated with questions, absolutely flooded with questions from our community and beyond, which is super exciting. Well over 1,500 questions came flooding in. From developers diving into the tech, questions from researchers asking about implications, and a lot of folks just trying to wrap their heads around, what verifiable AI means for the real world and for the future. And honestly, we couldn't be more excited. Your questions were very thoughtful and covered so much ground that we knew we had to dedicate an entire episode to this. So today we're jumping into it. And joining us to tackle your questions, of course, is TC, our co-founder and CTO, who's been literally living and breathing zero knowledge proof since his PhD days at Berkeley. And honestly, if there's any kind of cryptographic challenge in ZK, chances are, that TC has either solved it or is 3 steps ahead, thinking about the next one. And we've got Sam Pearden, our CMO, absolutely instrumental in bridging the gap between, our cutting edge technology and research and the real world applications that will bring this to the world. So I'm really excited for this episode. I know that you guys are too, and we had a lot of questions, and we've built this around them. So let's jump into it, because I know you're all just as curious as I am about the future of trustworthy AI. So thanks for joining us today, Sam and TC.
Thanks, Tony.
Let you guys take it all.
Thanks so much, man. All right, TC, we've got a lot of questions to get through here, and I know we both don't have a lot of time. So question 1, what specific machine learning models are best suited for zkML?
Well, I don't think there is a word called best suited. It's the current zkML tech stack basically works for every single model, as long as you follow the classical way of developing models. I think it's suited. Yeah.
Okay, right on. How are the model weights and architecture embedded into the ZK circuit in this demo? Are you using static embedding or dynamic loading?
It's compiled into a ZK circuit. I'm not sure about this static embedding or dynamic loading. I would say neither. Then it's just the direct compilation into the circuit.
Okay, thank you. Is the demo using ZK Starks, or a proprietary Polyhedra ZK stack like Paraplonk?
Let me correct something. I'll always say this to anyone. ZK Stark and ZK Snark are not on the same level. They cannot be put in the same sentence like this. Okay. ZK Stark is actually a part of ZK Snark. It's just a subset of it. We are, according to definition, we are using expander, which can be either using trusted setup or not using trusted setup, depending on your configuration. So, yeah, I think I answered that. Yeah.
Okay, thank you for that clarification. Super helpful. What proving system is running under the hood? Is it tuned for this specific model architecture, or is this demo generalizable to others?
It's generalizable for others. As I mentioned in the last question, it's expander, where it's a general purpose ZK proving system.
Okay, thank you for clarifying. All right, next one. How do you make zkML fast enough to run on devices with limited computing power?
Well, so you improve the algorithm itself. We are not doing any trade-off where you purely improve the algorithm, purely improve the speed. Then you can have like 10 times or even more faster than older generation of algorithm. Yeah.
Very cool. What are the current hardware requirements, e.g. CPU, GPU, memory, for running zkML proofs on advanced models like Llama 3? And how do hardware accelerators like FPGAs and ASICs factor into making this practical at scale?
Well, it uses quite a large amount of memory. There's several hundreds of gigabytes of memory to do stuff like Llama 3, like large language model. And as for FPGA or ASICs, I don't want to comment on that because I don't think it's going to come any near time soon, because the whole algorithm is bounded by the memory bandwidth, where the high bandwidth memory module definitely go to the NVIDIA's GPU, where other ASIC providers were not able to get that within a fair price. So I think given this, then we directly go use GPU. That's better for pricing and anything else and performance. Yeah.
Okay, awesome, man. Thank you for clarifying. Is the prover setup GPU accelerated during the demo?
No.
And if so?
No, it's not. It's a CPU, single thread CPU for demo.
Okay, great. All right, moving on to developer access and circuit conversion. Are there plans to open this demo framework to developers for plug and play verifiable model development?
Yeah, we will open this not a demo, but the tech stack to the developers, so they can plug their own X models into the zk environment and try it. Yeah.
Okay. Thank you for that. During the zkML demo, actually, that one doesn't make any sense because the demo has already been done. For ML developers interested in integrating zkML, but without deep cryptographic expertise, what's the learning curve like for tools like zk PyTorch? And what researches and frameworks does Polyhedra offer to empower them to integrate zkML into their existing ML workflows?
Well, I don't think there is a deep learning curve. You just need to compile your model into ONX format, and you need to better quantize it according to our spec. That's it.
Wow, that's very cool.
Yeah.
Very cool. Super scalable. Can you explain the role of the expander compiler in zkML and how it improves the efficiency of zero knowledge proofs for machine learning inference?
When you map, when you look at classical compiler toolchain, the expander compiler is more like a assembler in assembler position in classical toolchain, where zkML compiler is actually the front-end compiler. It compiles the model into some intermediate representation, and the expander compiler takes that representation and compile to the general to the bytecode that the prover can recognize. So it's more like in the middle where some sort of optimizations happens there. Yeah.
No, thanks for explaining that. It's I'm always fascinated to learn as well about how the different elements of research you've created fit into the output. So now we're on to security, trust, and trade-offs. While exploring the potential of zkML, I've often wondered, how do you ensure the balance between model accuracy and the computational overhead of zero knowledge proofs during this live demo?
Well, the topic here, security trust and trade-offs, are making me a little bit. I don't like this topic. I mean, I don't like doing trade-offs at all. I mean, doing trade-offs is like meaning that you are weak. You cannot improve something without sacrificing other things, right? It means that you're basically weak.
Sure.
And in this case, I don't think we sacrifice model accuracy. It's just quite standard quantization, and the computational overhead of zero knowledge proofs is purely improved. So no, there is no such trade-off between these two. Yeah.
Thank you for explaining that. How does zkML address the scalability issues of traditional blockchain-based machine learning?
I cannot comment on a thing that doesn't exist.
Okay.
Yeah, there is no such blockchain-based machine learning. I don't think there is. Yeah.
Maybe can you clarify that, or maybe we can just let the audience member use ChatGPT, right?
Yeah.
Great. Okay. So let's move on to real world use cases and vision. So this is a big one that we discuss a lot. And I might ask one more question after this as well. What are some potential use cases for zkML in real world applications?
Yeah, we got a lot of different use cases. One is for AI agents that may need permissioned access to APIs. Then the API provider need to know whether you are an authentic agent that already got my permission, or you are a malicious agent that don't have this permission. So it's basically you want the zkML or similar techniques can get an identity card for the AI agent that other people can distinguish that whether you're good or you're bad, or you got a permission previously or you don't got the permission previously. Yeah.
No, that's a super interesting one.
Yeah, or zkML can also be used in like privacy preserving KYC process, where you don't need to reveal all of your information to the provider or to the service provider, and you can still get access to some content. Like for example, you don't need to reveal your name or your face to a service provider, where they only need age verification. Right.
Yeah, nice. No, that's super useful, I think, in the age we're entering into. Sorry, one sec. Perhaps this is a bit out of the box, but as a content creator watching this demo, what's one fun way you think zkML can help someone like me protect my creative ideas while using AI tools?
Yeah, sure. So when zkML get scalable enough, then it can basically be used as a tool to audit the AI training set or AI fine-tuning data set, where you can have an idea on whether your creative content is being used or not in the AI training process. So similar things can happen in, for example, regulators can check whether there are some violations in the data set or not. Yeah.
Well, yeah, I mean, that's such a hot topic. There's been thousands of musicians and filmmakers, signing petitions to make sure, that their ingredients aren't used in AI content creation. Do you think that zkML will play a role in that ingredient or recipe detection moving forward?
Yeah, definitely.
Yeah. Very, very cool. And we're just gonna do 2 more today.
Yeah, sure.
I really appreciate your time. For me, it's always great listening to you, and I know our community just enjoy it so much. So this is someone who's just getting into, getting into the space and learning about polyhedra. They've asked for developers who want to get started with zkML today. What's your recommended first step?
The first step is zkML. First step is to learn something about technology proofs, and you will know the performance characteristics, and you will know that how does it protect your stuff, like. Yeah, and then look at the other potential use cases, and to see whether it fits your need. And finally, you get to the last step where it's using it, and then using it is the most easy part of it. You just convert your model into a standard format, then we take care of the rest. Yeah,
Great.
Before using it, you think about it whether it's useful, and yeah.
No, that's awesome, man. No, I appreciate that. And the last one, I'm just gonna and this is one that I think you get frustrated with me a lot. So it's a good question to end on. What misconceptions about zkML do you encounter most often?
Misconceptions.
Yeah. So what people, like how I came to you, with a release that that basically a zkML does something that it shouldn't, and we have a discussion on that. Like, what can you explain to the community? Is there something that people think that zkML can do, or is that that it actually doesn't do?
Well, for example, some people may think that zk can perform, for example, privacy preserving training where it's not. For example, and some people may say, okay, maybe I can use it for privacy preserving inferencing where my input are protected. No, it cannot do that.
Got it. Yeah, nice. Just one last thing. We've got about 2 minutes. What's next? We've got zk PyTorch. Obviously the zkML demo was fantastic on Friday. What's your vision? What's your vision now? What are you working on currently?
Currently, we are working on parallelizing the prover, where GPU parallelization is the key to speed up the performance. And the demo is actually single-threaded CPU, or it's not going to be deployed in any device, and the zkML only makes sense when you get it on the GPU as soon as possible.
Very, very cool. All right, man. Well, thank you. I mean, whenever I ask you to come on here, you say yes. I really appreciate your time. I know how busy you are at the moment with all the work and research that's going into deploying these models that I'm personally so excited to be involved in. So thank you to everyone who tuned in today. And have a good evening, TC.
Have a good day.
Thanks, man. Take care. All right. See you guys.